Finding a Star 3, Vernal Equinox and the Right Ascension. I am Dr. Midway. I am a physicist and I'm learning astronomy. In a few videos, I like to share with you how to find a star by reading its coordinates. In previous videos, we project lines of latitude and longitude onto the celestial sphere. Latitude becomes declination, and the lines of longitude become lines of right ascension. The lines of right ascension are in hours. It's kind of strange. To understand that, we need to know vernal equinox. It is around March 21st every year. On that day, the day and the night are equally long. 12-hour daytime, 12-hour nighttime. The sun is shining on exactly half of Earth. Notice that the Earth's rotation axis is tilted by 23.44 degrees in this picture. The axis is tilting toward outside, out of the screen. This is a picture from a satellite, Equinox 2022. Day and night are equally long. This is a familiar picture in children's book explaining the 4 seasons. Here we focus on the March equinox. You can see the Earth is tilted 23.44 degrees. When we think Earth is fixed, celestial spheres moving from right to left. If we look from top to bottom, it's clockwise. To make it easy to explain, let's use a static picture. But remember, we think the celestial spheres moving from right to left. Here comes the right ascension. Right ascension is the number of hours behind the sun on March 21st, vernal equinox. What does that mean? Let's use Sirius as an example. Its right ascension is 6 hours, 45 minutes, and 8.917 seconds. Let's round up to 7 hours. The sun is at 0 hour. Sirius is at 7, which is here, and the declination is minus 16. So it is about here. This is a minus 15 degree. Remember that celestial spheres are moving from right to left. So indeed, Sirius is 7 hours behind the sun. So what? This is important in stargazing. I'll show you why. Location is Twin Cities. 45 degree north is the latitude. And the time is 2025 vernal equinox, March 20th. It's early in the morning with the rising sun. 7 o'clock, see sunrise. 9 o'clock, let's turn off the atmosphere, so there's no scattering of light. You can see the stars. 10, 11, 12, 1 o'clock, 2 o'clock, sun is passing the observer's meridian, right? Passing the highest point. And let's see, where is Sirius? Sirius has a right ascension between 6 hour and 7 hour. The 6 hour line, 7 hour line, somewhere in between. Let's see declination. Declination, this is 10 degree, 0 degree, minus 10, minus 20. So somewhere here it's about to rise. Okay, there it is, 4 o'clock in the afternoon. Sirius is rising. Remember, I turned off the atmosphere. What happens if I turn it on? We actually cannot see it. The sun is too bright. So let's keep going. 5 o'clock, 6 o'clock, 7 o'clock, sunset. Still not there yet. Okay, now we can see Sirius. Sirius has been rising from here above, passing the observer's meridian, right? So this is a really good time. 6 hours and 45 minutes after sunset. Sirius is high up in the sky, so we can easily see it. Let's keep going. 9 o'clock, 10 o'clock, it's sighting down. The midnight is going to disappear soon. Yep, that's it. So for stargazing, you want to see Sirius, March 21st or 20th will be a very good time. Let's take a look at Vega, Another example. It is a very bright star, as in the constellation Lyra. Here are the coordinates from Wikipedia. Its right ascension is 18 hours and 36 minutes. So Vega is 18 hours behind the Sun on March 21st, vernal equinox. It's on the other side of the celestial sphere. We can roughly see here 16, 17, 18 hours. But wait a minute. Is it the same as 6 hours ahead of the Sun? Yes. Remember, the celestial sphere is moving from right to left. So 18 hours behind is equivalent to 6 hours ahead. What does that mean in stargazing? When we talk about Sirius on March 21st, after dinner, we can see it above in the sky. Can we also see Vega then? Vega is 6 hours ahead of the Sun. So at sunset, it has already set 6 hours ago. So we cannot see it in the evening. Then what? After sunrise, we definitely cannot see it because the sun is too bright. Can we see it before sunrise? The sun rises at, say, 7 o'clock in the morning, assuming we are at a north 45 degree. Since Vega is 6 hours ahead, it has already risen for 6 hours. 6 hours in a 12-hour night at the equinox, meaning it's around its highest point at the observer's meridian. With that argument, we should look it up right before sunrise. Where to look on the observer's meridian? We learned from the previous videos. Use declination to subtract latitude. That is 38 minus 45, and we get negative 7 degrees. Then we point up to the zenith point and swing south by 7 degrees. Well, 7 degrees is not that much. So we're pretty much looking around the zenith point. Now we are at a 45 degree latitude north in the morning, March 21st, 2025. The sun is about to rise. Let's see if we can find a Vega near the highest point, near the zenith point. This is our observer's meridian. This is south. Oh, Vega is right there. This is zenith point. I finally figured out how to put this label there. That's Vega. 1 more hour, it's gone because the sun is rising now. So let's go back and shrink the screen, go to the fisheye. Let's see where the Vega rises and how it moved. Okay, now Vega is hiding here. This is the observer's meridian, and you can tell where is Polaris. This is a Big Dipper. In the end, those two stars pointing at Polaris. So this part of the sky, well, actually the whole sky is rotating around Polaris, right? So the Vega will rise from here and moving around like this, around the Polaris. Now I'm going to speed up the time. See, now it's 0, the midnight. Vega rises, moving around the Polaris. Getting close to the zenith point. 5 o'clock right now in the morning. Oh, sun is rising. Oh, about to disappear right before it passing the observer's meridian. Okay, I'm going to stop it now. Hold on. There's no label in the sky. How do I tell which one Vega is? And we don't have equipment to point at the exact right ascension and declination. We can use smartphone. We already know which area to look around. But how about find it by the old-fashioned way? Vega is close to other bright stars, Deneb and Altair. especially Deneb, is part of the flying swan, the constellation Cygnus, also called Northern Cross. Those three bright stars, Vega, Deneb, and Altair, form another famous triangle called a summer triangle, because you can easily spot them in the summer evening. But now it's winter time, we can only see it before the sunrise. Why is that? We can explain it in the next video. Another question is, remember the first video we talked about heliacal rising? Sirius and its sun are rising at the same time. But on vernal equinox, Sirius is 6 hours behind the sun. What's going on there? The answer is in the next video. If you like this one, please subscribe, like, and comment. Thanks for watching.